right, class, let's see if we can now use these rules that we just talked about to take derivatives of these functions. Okay, so here, given the function f of x, what is its derivative? Now, one common mistake that students make is not to write that you are now finding the derivative. So I'm just going to show you now that I wrote it. It's a little bit too late, but I'm just going to show you what I mean in a second. So the derivative of this function, clearly we're just going to use the power rule that simply says that what? We're going to take down the power of 10 times x2, 1 less than 10 is 9. That's the answer, done. Now, again, I was just saying some students will take the derivative and will say, well, obviously, we're going to use the constant product rule. So the x's are multiplied to a coefficient, right? This 6 is the coefficient, in other words, a constant factor, times, moving on, so I keep the 6 and I move on to take the derivative of x to the fourth, which is 4x to the third. So that's just going to be further on 24x to the third. Now, what did I do wrong? What I did wrong was that I did not write anywhere that this is the derivative. So I'm not even sure what this here means. Is it still the function, which is, again, another common mistake for students to make, is to keep on going and say the function equals to 6 times 4x to the third. No, 6x to the fourth does not equal to 6 times 4x to the third. They're just not the same. Okay, the derivative is that. So you need to write this symbol down to let me know that you are now finding the derivative. Okay, so here it is. Find the derivative. Okay, here I'm finding the derivative, and I'm writing this so everyone knows. Okay, what do I have here? I have a whole polynomial function, right? So the sum of a whole bunch of terms. Now, what we're going to use first, and the way I look at it and break it apart, is that I have a sum difference of a whole bunch of terms. Now, the sum difference rule says if you do have that, you're just simply going to go term by term. So I'm going to take the derivative of 3x to the fifth. What's the derivative of 3x to the fifth? Well, it's what we did right before. Again, it's a coefficient times, so that constant factor of 3 times the derivative of x to the fifth is 5x to the fourth. Then it says move on, keep the sign, and take the derivative of the next term. So the derivative of 5x squared is, keep the 5, and move on to the x part. So the derivative of x squared is, again, 2x to the power of 1. I just wrote it for now, but plus, move on to the next guy. What's the derivative of 7 times x? Well, keep the 7 times, take the derivative of x. If you remember, the derivative of x is 1. Okay? Minus, move on and take the derivative of 8. And that's a constant, right? It has no variable to it, so its derivative is 0. Okay? So putting this together, the derivative is 15x to the fourth minus 10x plus 7. Now, you can leave it just like that, continue to the side wherever you have the room, but it's clear that we're talking about the derivative function. If you may want to make it even more clear, you can just put the f prime right in the front, box your answer, and there's no arguing that you found the derivative of this function. Okay, let's move on to the next one. What do I do about the square root of x? Well, just as we discussed earlier, in order to use the power rule, we're going to have to rewrite this function first as a power. So I'm not yet taking the derivative. I'm just using algebra to rewrite the square root of x as an x to the power of 1/2. And now I can use the power rule to take its derivative. So I'm going to write this down. Now, we have two ways of writing that. y prime, right, for the derivative of y. This one, even more so, might be helpful. Usually when we see a y, to write the derivative of y, we write dy dx. Again, we're using Leibniz notation for that. So either one of them is perfectly fine. You can write df dx as well, by the way, for f of x. But either notation's fine. Now let's go on and take the derivative. So using the power rule, we're taking the 1/2 up front times x to the, I'm going to write this down, 1/2 minus 1. So we have to go down in power. Now what are we going to get if we are subtracting 1 from 1/2? Clearly, even less than 0, because a half is less than 1. So we're going to get a negative 1/2 exponent. Okay. Now, as you've learned, an expression is not considered simplified if you have a negative exponent. So I'm going to continue on this derivative by fixing the negative exponent and making it positive. Okay, so this is a 1/2. Again, multiplying fractions, I'm going to multiply straight across. And x to the 1/2, I can rewrite it back as a square root of x. So here's my answer. Now, do you have to fix negative exponents? Yes. Okay, it's going to say make sure your answers do not have negative exponents. Okay, so you need to, so just because you could find a derivative doesn't mean that you should stop right there. Same as with the quadratic formula, right? Just because you can write all those numbers in the quadratic formula, it doesn't mean you're going to leave it like that. You still have to simplify your answers. Yes, so there it is. So basically this is what I did. I'm getting a negative exponent in my answer. I need to make it positive. How? By putting it on the bottom. You don't even have to go through this in between step, because where will this x end up? Under the fraction line, right? Under the fraction line next to the 2. So you could have thrown it right there. Can you leave it as an x to the 1/2? Yes. It doesn't, it's not a negative exponent. The reason why I wrote it back as a square root of x, it's because the problem started with a square root, so it would be nice to write the answer with a square root. By the way, if you look at the end of section 1.2, there was a problem where we find the derivative of a square root function using the limit definition, and we had to use the rationalizing the numerator method, if you remember. So this is definitely way faster. All right, let's continue. Okay, same thing here. I cannot take the derivative of this quotient as it is. We don't know yet, or you don't know yet, the quotient rule. So how do I deal with this? I'm going to first of all rewrite this function. 4 over x to the 6 is the same thing as 4 times an x to the negative 6. So this x, when moved up to the top next to the 4 by switching the sign, yes, of the exponent. Okay, so now the derivative of y, this being the function y, is going to be what? Keep the coefficient times, bring the exponent up front, that's a negative 6, x to the 1 less than negative 6. I'm going to write it down so we don't mess up. What is negative 6? Take away 1 more. Sure enough, that's a negative 24. Yes. X to the negative 6 minus 1 more, that's negative 7. Yes, as you move down into the negatives, they become larger. Now, this is an expression that has a negative exponent. The negative exponent has to be fixed, so it gets thrown under the negative 24 coefficient, right? The negative 24, that's not a negative exponent, so it stays, right, as a numerator number, yes? The x to the 7th, or the x to the negative 7, I should say, has to move on the bottom. Okay, All right, so we're getting a hang of it. Anytime we have radicals or fractions, we're going to rewrite them as exponents, yes, because that's when we can use the power rule. Okay, so I'm going to continue here, and I'm going to rewrite my function first of all. I'm not yet taking the derivatives. I'm just going to prep my function. So this is going to be an 8x to the 3 divided by 4. Remember what we just reviewed. Minus, this is a fraction, so this x is going to have to move to the top, and we're going to give it a -2 exponent. Okay, so that being said, I'm now ready to take the derivative. Okay, so what's the derivative of this function? I wrote down that now I'm ready to find the derivative. Yes, I put the derivative symbol. So the rules say if you have a coefficient, you keep it, times, throw the exponent up front, x to the, let's not make a fuss, but start subtracting now. So what is 3/4 minus 1/2? So 3/4 minus 4/4, by the way, is -1/4, yes? Minus, take the derivative of this second term. So the -2 is going to come up front, x to the 1 less than -2, so -2 minus 1, that would be down at -3. Okay, and now I'm going to fix this answer. Well, 8 times 3/4, that's a 6. What do I do about this factor that has a negative exponent? Well, it has to move in the denominator to make it positive. So x to the 1/4. Minus minus, that turns into a plus 2. And what do I do about this x to the -3? Well, to make it a positive exponent, I throw it in the denominator and make it an x to the 3rd. There you go. This is a perfectly fine answer. One thing, if you want to rewrite it back as a radical, you don't have to, but the x to the 1/4 is the 4th root of x. Don't think about rationalizing. That's a whole different beast. As I said, you don't have, the only thing you have to do is fix negative exponents. Okay. All right. Okay, 2 more. So we're getting a hang of it. Let's first do what? Rewrite our function. So I'm not taking yet the derivative. I'm just rewriting my function. So 5, the cube root of x can again be written as what? X to the 1/3 plus, I don't have to rewrite anything here. This x already has a positive exponent. It's not a fraction or anything like this. 3/4 or 0.75, that's just the coefficient. No big deal. So again, what are we fixing? Radicals, and x is in the denominator, right? So fractions with variables in the denominator. So that's all we had to fix here. Okay, so now what's the derivative? Keep the coefficient, times the x to the 1/3. The power rule says throw the exponent up front, x to the 1 less than 1/3. So 1/3 minus 1 is -2/3. Again, you're very welcome to use your calculator for this. It will tell you. So keep the coefficient, and then x to the 4th, what do I do? Throw the 4 up front, and then decrease that power by 1. Minus, what's the derivative of x? 1. Plus, what's the derivative of a term with no x in it? It's a constant. Yes, that's going to be a 0. You don't have to write that. That's perfectly fine to just leave it, because you know already it's not going to go anywhere, so that's fine. Okay, now let's fix the end of this. 5 times a third is 5/3. I see a negative exponent. What's this negative exponent going to do to that x? It's going to throw it on the bottom, right, next to the 3. So that's x to the 2/3. Plus 3/4 times 4, that's a 3. X to the 3rd, that's fine, minus 1. So here's your derivative. Okay. Again, when watching these videos for them as much as you can, what I'm encouraging you to do is do your own work. In other words, what? Okay, fine, you went through a few examples. Now pause it and see if you can do the problem. Yes, that's what I would do if we would have the luxury to be in class. I would give you a problem. I would give you 5 minutes, a few minutes. You guys get started. See, again, there's no substitute for you doing the work and you trying, okay? So treat this as your class lecture. Even more so, you can't stop me in class maybe sometimes, but you could definitely stop me on the video. So pause me, try it yourself. I will go through it definitely, and then see if we end up with the same result. And if we do, then that's awesome. Okay, well, maybe I'm making a mistake and you can call me on it. All right, so here it is. First of all, I still have my function y. All I'm doing is prepping it. I'm not ready to take the derivatives. Why not? I see some fractions with x's on the bottom, even the radicals. That's no good. So I need to change everything to a power. So how do I get this x part out of the denominator? Bring it up and give it a negative exponent. By the way, it is up next to the 2, but it looks better to the side so that you separate the coefficient, in other words, the numerical factor, yes, from the variable factor. Minus 3x to the 7th, fine. But this one I need to fix, right? So 4 is the numerical factor, or the coefficient, yes. And then this square root of x. First of all, the square root of x is an x to the 1/2, but it's still on the bottom, so how do I bring it up? Well, I must give it a negative exponent. That's how it's going to come to the top. And its exponent comes from a square root, and that is a 1/2 exponent. Okay, and finally, minus 9. Great. So now let's take the derivative. So just to change it up a bit, I'm going to write dy dx for the notation. Okay, so I get 2/3 times negative 3 that comes down. X to the 1 less than negative 3 is negative 4. Minus 3 times 7 comes down. X to the 1 less than 7 is 6, plus 4 times negative 1/2 comes down. X to the, what is 1 less than negative 1/2? So negative 1/2 minus 1 more, and 1 is, by the way, 2/2, yes? So that's going to be negative 3/2. But as I said, ask your calculators if you're not sure, okay? But that's a negative 3/2 exponent. And where does the negative 9 derivative go to? That's going to be a 0, right? Okay, so that's going to equal to 2/3 times negative 3 is negative 2. This x to the negative 4, well, it has a negative exponent. I have to fix it. So I'm going to throw that x to the bottom, and now the x has a positive 4 exponent. Minus 3 times 7 is 21, x to the 6, that's a perfectly fine exponent. And then 4 times negative 2, 1/2 is negative 2. And then I have an x to the negative 3/2 exponent, so that x to the negative 3/2 is going to have to go in the bottom as an x to a positive 3/2. Okay, so there it is. All right, now we got some practice. Now let's continue. What we're going to continue with is still taking a whole bunch of derivatives, but for some reason. So we're going to be doing some business applications. So what is more business than talking about cost, revenue, profit, and then marginal cost, revenue, and profit? So let's start one thing at a time. What is cost? Okay, and again, if we're in class, you might just yell out a bunch of things, what cost might mean to you in business. So sure enough, when we figuring out the cost of running a business, we simply mean the cost involved in producing something, producing some items, such as materials, labor, in other words, your salaries, overhead, rent, rent for the business, what else? Tools, machineries, and again, all sorts of things. Maybe you're not even producing something. Maybe you have just hair salon, right? Or some kind of business, some kind of beauty parlor, right? So you're providing a service. You are a doctor's office. Yes, that also has to be running. There's definitely salaries, right? There's definitely overhead. There's definitely rent. Yes, there's definitely materials. Yes, that you have to be spending on. So cost is anything that you have to spend to run your business. Yes. Okay. Now, when talking about cost, this is going to be important too. We have something called variable cost versus fixed cost. That's going to come up a lot as well. The fixed costs are, the variable costs are. What is a fixed cost? A fixed cost is something you cannot change, right? So a fixed cost could be, if you're looking at this list, would be what? The rent you're paying, which again, yes, can be changing. Maybe your rent goes up or so, but it's definitely an amount that you have to spend the same every month, right? So it's fixed. Maybe the machinery you've already purchased, right? That's a fixed cost. What is a variable cost? Something that you have to keep buying, right, in order to produce your items. That would be the materials, right? The more you produce, the more you have to buy. Yes, you want to produce 10 items, you have to buy the materials for 10 items. The rent is still the same whether you produce 10 items or you produce 1,000 items, right? So that's what variable cost means versus fixed cost. Salary, maybe employing 10 people and then you let some go, you hire new people, and so on, right? So, okay, so I know you have an idea. Maybe you had other things you wanted to shout at me. I'd be glad to hear about those when we meet on Zoom. What is revenue? Well, revenue is the amount of money you're going to make, right? From selling the items you've been producing, right? Why are you producing them for, right? So the amount of money you make. And again, maybe you're not producing something, maybe you're providing a service such as cutting hair, right? The revenue is whatever you're earning from cutting that hair, from making those nails, from seeing those patients, right? Whatever service you are providing. So the amount of money you make. From selling your items or providing the services. Okay, all right. Now, unfortunately, there is no such thing as fixed cost. No one just gives you money for nothing. Oh, here is a fixed $1,000. Every month, I just feel like giving you $1,000 without anything in return, right? There's no such thing. Okay. So, putting this together, what is profit? I feel many students actually make a big mistake on this, but I feel as business students you should know that profit is simply revenue minus cost. So whatever you're making minus whatever you had to spend to produce or to provide those services is money left in your pocket, yes? So you have to spend $10,000 a month for whatever fixed cost, variable cost you have, but you're making $20,000 that month. Well, the $10,000 difference, that's yours to keep. Yes, you've paid all your salaries, you've done, right? Take care of your costs. So that's money, that's your profit. The break-even point, I'm going to write this down. That comes up a lot. Is the point, all right, or the amount or the point in your business when what? When revenue equals to the cost. Okay, so in other words, when your profit is equal to what? That's right, 0, right? So when revenue is equal to cost, then the profit is 0. So you all know when you're starting a business, there's definitely a lot more cost involved than revenue. Why? Because you had to buy the machinery first, yes? You had to hire those people first. You had to buy all those tools, yes? Pay the rent before you even start producing, yes? And start selling anything. But once you start selling and you start making that profit where your revenue every month hopefully overturns your costs, right? Slowly, slowly you start making back for the fixed costs you had to put in first before you even got started, right? Okay. All right, so here it is. There's one example. So, before we get started, because I see already the word marginal cost, what is marginal cost, revenue, and profit? So we know what cost, revenues, and profits are. Marginal is simply a name for the derivative of cost, revenue, and profit. So when I say find the marginal cost, means to find the derivative of the cost. Find the marginal revenue means to find the derivative of the revenue, and so on. Okay, so here's our first example. The cost of producing an amount of X scientific calculators is, so I'm giving you a cost function, okay? All right, it says to find the marginal cost. So what does it mean to find the marginal cost? We write MC for that, for marginal cost, but what it really means is the derivative of the cost function. Okay, before I even find this marginal cost, it looks to me like I have to fix up the cost function, right? Why? Because I have a radical. So I am going to rewrite the cube root of x squared as an x to the 2/3, right? Plus 400. And now I'm good. So what's the derivative of this? Well, according to my rules, you'll keep the 5 coefficient times the 2/3 comes up front, x to the 1 less than 2/3, or 2/3 minus 1 is negative 1/3. And then the derivative of 400, that's just 0. So I'm going to fix this up for you. 5 times 2/3, that's 10/3. This x has a negative exponent, so I'm going to put it on the bottom next to the 3, and I'm going to make it a positive 1/3 exponent. Okay. Now it says find the marginal cost function when 27 calculators are produced, and interpret this answer. So marginal cost at x is the number of calculators. So all I have to do is plug in 27 into this derivative function we found. So basically evaluate the function for this x. Okay, so it's going to be 10 over 3 times 27 to the 1/3. So 27 to the 1/3, by the way, the cube root of 27 is 3. 3 times 3 is 9. So that's about 1.11111. Now, that's fine. Interpreting the answer might be the tough part. So, again, what is a marginal cost? It's a derivative, right? So the derivative of a function tells me how the what? The function, the derivative of a function is the change, I should say, in the function values with respect to the change in the x values, right? That's what a derivative is. So it's telling me how the function's about to change with respect to a change in its x variable. So keep that in mind every single time when you interpret derivatives. So I'm going to say that what? Now, does the derivative of this function change in time? In other words, is the derivative always 1.1? Or did we get this 1.1 only because we plugged in 27? Clearly, if we were to plug in a different value for x, we would get a different answer. So that means this 27 has to be acknowledged. So you can't say the function's changing 1.1. When does this happen, right? So important thing is that you start acknowledging the number you plugged in. So when 27 calculators are produced, the cost is what? Did you get a positive or a negative derivative? We got a positive, so that means it's an increase, yes? It's a positive slope, so the function's going up. So the cost is increasing by how much? And since it's a dollar amount, right, we're going to only keep 2 decimals, so 1.11, so $1.11 per, it's a change, right, calculator for every 1x. So in other words, the cost is going up by $1 for every extra calculator you are producing right now. Now I'm not sure what the cost is at 27. We could plug that in. You could plug in the cost at 28 and you'd see the difference is about $1.11. Okay, so you're welcome to plug in that. By the way, just to be clear, what if we would have, this is what I was saying, what if I would have wanted to find the marginal cost at 1. So if I'd plug in a 1 in here, what would I get? 10, I'd get 10 over 3, right? Which is what? 3.33. So when you're producing one calculator, after the first calculator, the cost is going up by $3.33, right? So sure enough, the more we produce, the more the cost is going to get tempered, right? Because that fixed cost starts getting split up over more and more and more items. This is why the cost should be going down per item the more you produce. So I'm just showing you that it depends on what value you're plugging in, right? Okay, almost done. It says the revenue from selling these calculators is given by this function. Find the marginal revenue, okay? Marginal revenue, again, means to find what? The revenue function, the derivative, right, of the revenue function. Now, if you look at this, there's something wrong with it. I don't know how to take the derivative of a product. Product rule, by the way, is coming up in the next section. So, can we overcome this product? Can I do something so I don't have a product anymore, but I have a sum or a difference because I know how to deal with that? So sure enough, the easiest way is to simply multiply it out. So x times 12 is 12x minus 0.1 x squared. So now I'm dealing with a sum of terms, which we know what to do about. Okay. So now I'm ready to find that derivative. What's the derivative of 12x? Well, that's 12, right? Times 1 if you want. minus 0.1 times, the 2 comes down, yes, x to the power of 1 less than 2 is 1. So I'm going to get a 12 minus 0.2x. Okay. Find the marginal revenue when 27 calculators are sold and interpret this answer. So now I've explained plenty, so we know now we're plugging in a 27 in there. So let's see, let me use my calculator really quick here, or just look this up. Okay, so that's going to come up to a 6.6. Okay, so what does that mean, the interpretation? That means that what? Again, remember, we got this value only because of the 27. So when 27 calculators, I'm just going to are sold, the what? The revenue, yes, that's the function that's changing here. The revenue is again increasing because you got a positive slope. By how much? This is a dollar amount, right? Revenue is dollars. $6.60. So again, I'm going to write it with 2 decimal places per calculator. There you go. Find the profit function. What is, first of all, the profit, yes? So the profit function is simply the revenue function minus the cost function we had. Now the revenue function, I might as well write it in this distribute form, minus, what was the cost function? I'm going to also write it in my rearranged form. I'm going to look back. That was 5 x to the 2/3, and then remember it was plus 400, but because I'm minusing them both, it's going to be a minus 400. Okay, so this is the profit function. I simply got it by doing what? Subtracting the revenue, yes, function that I gave you, minus the cost function from the previous page. Find the marginal profit, which means the derivative. You don't have to write them both. I'm just writing it out. One or the other is fine. I'm just writing them both for you. So the derivatives of all these are 12 minus, I'm going to do this a little faster, that's a 0.2x, minus 5 times 2/3 is 10/3, x to the negative 1/3, which is going to get put down as an x to the 1/3 at the top. And then the derivative of 400 goes to 0. So, would you have been able to guess this without actually going through? Sure enough, because that's the derivative of the revenue minus that's the derivative of the cost function, right? We are simply using the sum difference rule that says that what? When you take the derivative of a difference, you're going to take the derivative of the first minus the derivative of the second. So as you very well see, this was the derivative of your revenue function. And I'm going to bring back the previous page. This here was the derivative of your cost function, right? So you don't have to reinvent the wheel. You already had found them, right? All you have to do is subtract them. Okay, so find the marginal profit at 27. And again, I'm sure you are guessing that you didn't have to reinvent the wheel on this either. Oops, minus. Because again, what's going to end up being? It's just going to be the value you got for the revenue, marginal revenue at 27 minus the marginal cost at 27. So that would the 6.6 minus 1.11111. So put that in your calculator. That's about 5.49. And again, I'm just stopping at 2 decimal places. Okay, approximating for 2 decimal places. All right. So again, what does that mean? It means that when 27 calculators are produced and sold, at that point in time, the profit is increasing by how much? $5.49 per calculator. And there you go. That's your section 1.3. So we're going to do a lot more profit, revenue, cost applications. What we're going to be doing in the next sections is just making these functions more complicated. Okay, so this video went a little bit long, but at least I got through this section in 2 videos.